There are the numbers going. I'll let the numbers kind of level out before getting started. Looks like it is leveled out. All right, well, good morning, everyone. This is our July 13th Safety Council meeting. Oh, I messed up. Okay, so we'll start with PAR and prayer. We'll move over to pledge, do some announcements, and we'll get this the meeting really going. So PAR, it's all yours.
All right, let's bow. Father God, we say this, Lord, we love you, and we thank you, Lord, for another day that, Lord, there was somebody on last night that didn't wake up this morning. We just thank you, Lord, for that opportunity again. We lift every company and every agency up to you today, Lord, that, Lord, they'll keep their safety in their locations, Lord. We thank you for everyone that is on this line. We thank you for the Safety Council, Lord, as they lead us through a number of things pertaining to safety. Lord, we ask that you bless the speaker on today and that you receive all the glory and the honor for all the things that we're involved in. It is in your name I pray. Amen.
Thank you, PAR. So now we'll do pledge.
Allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
It's been a month, so I've already got confused here for a minute. All right. So thank you for all that have called in on this meeting. Unfortunately, we will be doing the Zoom setting format through next year. I know we hope that the worst of COVID is behind us, but we still will be doing these Zoom meetings from this point and through next year, June. So please continue to call in. We try to bring good speakers still, even though we're not eating breakfast and enjoying each other's company. We still try to bring a good program. So that said, if you have not attended, I tried to use this disclaimer. This is set up as a webinar type setting. So obviously you're going to see a handful of us on your screen. You will not see yourself, but that does not mean you can't participate. There is a chat box or a Q&A box at the bottom of your screen. So if you have any questions to me or to the steering committee or even to Stephen during his presentation, please don't hesitate to use those two functions to ask those questions. Depending on how Stephen wants me to interrupt or wait till the end, we can ask those questions throughout the meeting. But please don't hesitate to ask those questions. I will monitor those questions in the box. So with that said, I'm hoping everyone enjoyed their 4th of July. I know that was last week, so hopefully everyone had a safe 4th of July. I do have a couple updates. I know Jim has a few as well. Since our last meeting, OSHA has come out with updated guidance when it comes to the COVID and protecting your employees. The main focus is the healthcare industry. So if you're in that industry, I advise you to get on to OSHA's website. They've got a frequently asked questions, some guidance to that. But then if you're still concerned or still have some concerns how OSHA is going to treat things, they have a whole web page or a whole page geared towards COVID, what you should do as an employer, how you should protect your employees. So I advise you to go to there to kind of read through that. If you have any questions, please reach out to me and or Jim. I'm sure he'll be able to provide some guidance as well. Next month, our meeting is leapfrogging from compliance to culture. So Tim Page will be our speaker. He's from Safe Start. So I'm kind of excited for that. From what I understand, he's a pretty good speaker. And And I'm going to remind, I'm going to beat you guys over the head over this, but October 6th is the BWC mega meeting. I don't know if Jim will announce that or not, but we'll continue to announce that all the way through October, just to remind everyone of this meeting. It's not a normal safety council meeting like with our setting. It's everyone from the state of Ohio. So it's put on by the BWC. So there's August 6th, if I'm not mistaken, it's a Wednesday. So that's what, it's not a Wednesday, Jim, or it is?
It's October 6th. Yeah.
October 6th. I'm sorry,
Yeah.
October 6th. So maybe I need to beat myself over the head over that. So October 6th is the meeting. So I know it is not a normal, typical Tuesday morning meeting. The time is still to be determined. So please I will keep you guys updated. So please listen to those updates. With that said, I'll hand it over to Jim for a BWC update.
Yeah. Good morning, everybody. October 6th is, it's a Monday. So it's going to be a little bit different time for us. But yeah, I'm sure the announcement will come out at some point with the speaker and more details. So yeah, I'm Jim Pellegrino. I'm the safety consultant covering Clark County. I think most of you know me, of course, but there's always new folks on. So that's who I am. I will put my contact information in the chat, so you have that. Reach out to me if you have any questions related to the Bureau. And it's obviously safety questions. We're here to help you out. First talking point, I want to have some good news. Private employers, your rates are reducing starting July 1st. So they're down 7% from the previous year. They continue to go down almost year to year, plus the give back. So I got to imagine our rates are some of the lowest in the country, if not the lowest, with the give back. So that's all good news. Fewer claims. You guys are to be congratulated for that. Some changes to our industry specific safety program. If you're familiar with this program, we have a lot of employers that do this every year. It's a rebate program. It's compatible with only certain rating programs, so you may not be eligible for it. But if you are, there are some changes that started this year for private employers on July 1st, and then it'll start for public employers on January 1st next year. The biggest change is one of the activities you can do is have consultation with safety consultants like myself, Steve, and Brad, who are also on the call this morning. Following those consultations, you may be asked to do some follow-up activities such as an action plan for safety or a survey if we provide training. So it's not a big deal, not significant, but there's going to be some follow-up. Typically, you just had to take a quick survey for the consultation itself. But now you might be asked to do a few other things, but you'll be working with us directly and it should go pretty smoothly. Our transitional work grant. If you have a transitional work program and you've received the grant in the past, it used to be a one-time grant. Now it's available every 5 years. So the Bureau is recognizing that transitional work program at employers' places needs updated. And now that grant's available to you every 5 years. So keep that in mind. Transitional work programs are great for helping you reduce the costs associated with lost time claims. So it's a great program to have. If you're not familiar with it, give me a buzz. We'll give you some information. If you have one, consider updating it, and now you're eligible for that grant again. Some deadlines for our drug-free safety program. If you participate in the Bureau's drug-free safety program, your safety self-assessments due July 30th. If you're in our advanced level, your safety action plan is due August 30th. So keep those dates in mind if you're on our drug-free safety program. Our indoor air quality assistance program. This program is a program that gives you money for improving your indoor air quality systems. And this is only for assisted living facilities. And this was this came out because of the pandemic. But that deadline to get that money, it's been extended to the end of this year. So if that affects you, your assisted living facility, be aware of that deadline. Steve is kind of our Dayton office expert on that. So if you have questions, let me know or let Steve know. Steve's our speaker today. Heat stress training, even though it's not going to be real hot today, we know July, August, it's going to be hot. And we have the Bureau just put out a safety talk to assist employers on talking to the employees about heat stress. And we also have a lot of new safety talks available on our website. And these safety talks are 1 or 2 pages, and they're designed to help lead you in leading a discussion with your employees on that specific topic. So be aware of that. To find those, just go to our website. You look at the little search icon, type in safety talks, and it should be one of the top ones that comes up. And you can find all our safety talks, multiple topics out there. So just be aware of that. We do have a webinar today. This is the only webinar this month. It's really for small businesses on managing workers' comp and safety programs. It's 11 a.m. today. So if you weren't aware of that, you could sign up to our Learning Center. It's going to be in Spanish. It's offered tomorrow at 1 p.m. So again, that's the only webinar we're offering. I do want to point out on July 15th, there is a webinar offered by Occupational Health and Safety Magazine. That webinar is going to talk about first aid requirements. And that brings up another point that we do have new written programs on our website, lots of new examples with attachments and additional information available to you. And again, just go to our website, click that little search icon and type in written. It's the first thing that comes up, and you can see all our example written programs that are templates in Word that you're more than welcome to use to help improve your programs or create your own programs. So don't reinvent the wheel on those, check those out. If you can't find them, again, let me know. As far as upcoming virtual training, I should point out that our classroom training has been canceled and will be for some time. But our virtual training, as far as what's coming up in August, we have on August 4th, lockout, tagout, and safety-related work practices. That's on August 4th in the morning. Okay, it's a morning class. On August 18th, we have work zone traffic control and safety. Again, that's a morning class. And then on August 23rd and 24th, a 2-day class on confined space assessment and work. So if you have confined space, you need competent folks in that, great class for that. And that's August 23rd and 24th. You can sign up for these classes and more at the Learning Center. If you have any trouble with that, reach out to me. I'm glad to help you out. And that's all I have today. Thanks for coming out to Safety Council.
All right, Jim, thanks. That's a lot going on. Appreciate the updates. So with that said, we'll go ahead and introduce our speaker for today. The topic is electrical safety. Steve is no stranger to us. If some of you may recognize him, he was our liaison, BWC liaison, a couple years ago, I think it was. So he's coming back to hang out with us today. Just a quick bio, and I'll turn the floor over to Stephen. Steve Roth is a ergonomist with the Ohio Bureau of Workers' Compensation Division Safety and Hygiene. He's been with the BWC for 13 years and has over 30 years experience in the field of environmental health and safety. Steve is a registered professional engineer, earning his degree in mechanical engineering from the University of Dayton. He is also a returned Peace Corps volunteer, having served in Kenya. So welcome to the Clark County Safety Council, Stephen, or welcome back, I guess. Just a quick, if there are questions, how do you want me to handle the questions?
Oh, I probably,
As they come at the end?
probably, you can go as they come. That would be fine. Yeah. Let's do
Okay.
that, Justin.
Okay, so the floor is yours.
All right. Well, thank you for inviting me today. It's good to be back with the Springfield Clark County Safety Council. Like Justin said, I was your BWC rep for a few years, but it's been a few years ago, I think back when, prior to Jim Pellegrino coming. So happy to be back here. All right. Just getting situated here. Well, today we're going to talk about electrical safety. And you've probably been through several electrical safety sessions or training sessions or webinars by this point. And one of the things that when I asked about, can you give a presentation on this? I thought one of the areas that's missing is electrical safety really for end users. When we look at electrical safety, and if we look at electrical safety in this giant book, the National Electrical Code, this is a little bit dated, but it's only gotten thicker. What we see is that most of these things have to do with like using well, installing electricity and how do we put in all the equipment and the gear and things that we can do and we can't do. But most of us aren't doing that work, right? Most of us use electricity to accomplish some other task. We're just truly end users. We plug things in, we push buttons to start things. And that's our extent of using electricity. We're not out there wiring buildings, wiring structures, pulling cable. That's not what we do. There's some of you in this room who may do that, either as electricians or maintenance staff, but most of us are just end users of it. We use it to accomplish some other task. And so what I wanted to do is create a presentation that looked at electrical safety in the workplace and then electrical safety that you can use at home as well. So these are some of the things that we see often where things can go awry. So let's run through this. So why is electrical safety important? Well, it's people get electrocuted. So we have a fair number of fatalities every year from electrical hazards. You know, most of them are due to direct contact. So being exposed directly to the current. So you're working on the current, you get exposed to it. Over half of the fatalities are that, but a fair number, 40-some% are fatalities that are indirect exposure. So you're not the one who came in direct contact with the line, but you were part of the circuit. And that's a pretty wide range of group of age, but what it tends to show is that most of the injuries or fatalities occur in the younger age groups, which in the safety world, that's usually what we see. And those who have a little less experience tend to have more of the accidents. Nearly 10,000 workers are injured every year from electrical injuries. Again, most of those due to direct exposure to the current. But the big thing to take away here is that the large number of days away from work, nearly a quarter of these injuries result in more than 30 days away from work. So when you have an electrical injury, usually they're pretty bad, and the outcomes are difficult and long. And from a workers' comp standpoint, very expensive as well. All right, so since most of us are end users, how does electricity work? Well, it's really just magic. You plug things in, they work, right? It's phenomenal, actually. When you really think about how all of this works, it's an amazing system that we've created and put into place. But really what's happening is you have this flow of electrons. We're going to energize electrons, and they're going to flow through conductors, and there's free electrons that flow through these conductors. And that's what we have. We have this flow of energy from a power source, and it travels in a closed circuit. And down here we see a diagram. This is basically a flashlight. We got a battery, current flows, it goes through the bulb here, the resistor, and then back to the battery. It's that flow of current that's really important to keep in mind, because what happens with electricity is it's always seeking to return to its source. So it goes out on a circuit and it wants to get back to where it came from. Now, in most of our cases, that's going to be that last transformer on the system. So that's the source. So here I'm in my home. The source is the transformer in the backyard. That's where this wants to go back to. Any current that I'm using wants to get back to that transformer. And that's how electric works, is it's always seeking to get back to its source. And that's a critical component to understand when we're talking about how do we stay safe when using electricity. Some terms, well, we've all heard the term voltage or high voltage, right? So voltage is the force that moves the electrons in the conductor. It's measured in volts. Current is the flow. So voltage is the force that's pushing the amount, it's pushing the electricity or pushing the electrons through the conductor. Current is then the flow, like how much is flowing through that conductor. And resistance is anything that's going to impede that flow. So bigger wires, lower resistance, you can get more current flowing through there. If we look at it in comparison to something we deal with every day, water. Water, we have pressure, which is the force behind it. but flow is the current. So if we open up a faucet and it just drips out, it may have pressure, but it may be a really small stream because there's just not a lot of volume there for the current to flow through. So, or the water to flow through. So you get a small amount. If we had a bigger pipe, right, you get more current or more water coming through that pipe. That's what we're looking at between voltage and current. And then again, resistance, any sort of impedance to the flow. I mentioned conductors a few times here. Now, conductors, they're any material which permits the flow of electrical energy. It's usually there's going to be some metal object, you know, copper wires, aluminum wires. In some of our electronics, we see gold and silver. But we also see human bodies up there, right? The human body is a great conductor because we're made of a lot of water, and water is a great conductor as well. So the human body is a conductor, and that's one of our challenges in this is that we don't want to be part of the circuit because we are a good connection for that current to get back to its source. Now, non-conductive materials are insulators. They're just any material that impedes the flow of current. And great examples are plastic coating on all your wiring, those glass, air, if we have separation, rubber, wood. Those are just examples of insulators, but we're all familiar with insulators on an electrical cable. And that's what we're looking at here is those insulators. All right. When I was putting this together, I had to call Jim one day and I said, Jim, am I allowed to talk about equations? And he said, Steve, definitely not. Do not do this. So I said, well, I'm going to put the word fun in front of it. So I'll have fun equations, not just equations. These will be fun equations. And so this would be a little bit better, right? It's fun. So Ohm's law, I only bring this up because there's certain equations in my world, at least in my head, probably not my world, that I use all the time. I use F equals MA all the time. I use Ohm's law all the time. I never use E equals MC squared, though we're all familiar with that one. But Ohm's law says that the voltage is equal to the current times the resistance. And so that is important, I think, when I look at, if I'm going from like a 120 to a 240 system, I know that I have more current or in a 120 than I'm going to have in a 240 because I can, for the same amount of work. So if I use a 240, I can drop my current load and still accomplish the same amount of work. Or if I use a 483 phase, I can use less current and do the same amount of work. And so that's what we see in commercial and industries, which is if we bring up the voltage, we can drop the amount of current that we need to accomplish the same amount of work. And when we drop the voltage or drop the current, we can also reduce the size of the conductors, which is critical, right? Because that metal is expensive. Now, Watt's law is another equation that I use when I'm trying to figure out how much power am I drawing through something. So Watt's law looks at power in watts. So is equal to the voltage times the current. Now you're like, Steve, what's this matter in my world? Well, I just had this situation happen the other day. I go and I needed to buy, well, I didn't need to buy, but the house needed to buy a hairdryer. I haven't used one of these ever, but nonetheless, we needed one of these in the house. So I go and I look in the store and I see this on the shelf. And I don't know if you can see this here. It says 1,875 watts. That's a tremendous number. And I'm like, wow. So I know a little bit about this. I look at that and go, man, 1,875 watts. That's a tremendous number of watts. How many amps is that going to take to draw this if I start using this hairdryer in my house? Because the current hairdryers in our house are not 1,875 watts. And from time to time, breakers trip from overuse or overload. So I'm like, a 1,875 watt hairdryer is going to cause maybe some problems for me. Well, if we use this equation, Watt's law equation, and we plug these numbers in, we end up seeing that this is 15.6 watts is the current draw that I'm going to have for this one hairdryer. Now, maybe your home is equipped with a 20 amp breaker in the bathroom. Mine is not. We have yet to use this. I'm wondering how long it's going to take for the breaker to trip when we plug that in and start using it. I may take it back because I know in a 15 amp circuit, if I want to have the lights on while you're doing this work, it may be a little bit more than the system can handle. So that's how I would use Watt's law. It's like, hey, how much current am I seeking to draw through this circuit, and does it fit into this? So you can start plugging in these equations in your mind and see how many watts, what's that end up being in amps, and then we can know, do we have a problem or not? And the same thing, like when we, Jim or Brad or I, when we walk around and we're looking at facilities and we see like a power strip with a bunch of stuff plugged into it, you start running these numbers through your head and you're like, you're drawing a lot more current through there than you should be. All right, so in our hazards of electricity, well, we're going to focus today on just those top three there: shock, fire, and burns. And we also have the other three hazards: arc flash and arc blast, and explosions. And when we talk about explosions here, we're looking at hazardous atmospheres, and the electricity provides that spark for ignition. So if for those who have a paint line, you may be familiar with these ideas, and we have to have explosion proof electrical systems in these areas so we don't create those sparks that cause us to have an explosion. But we're going to look today at shock and burns and fire. So our injuries, we have two main causes. We have these direct injuries where we come in contact with the water, and then we have indirect where we come in contact with the current, and we have indirect where we have came in contact with the source of the current, and that leads to an indirect injury. So in our main types of injuries, we have electrocution. Now, electrocution is a one-time event. It is shock to the point of death. Now, we also have shock, and many of you probably have experienced a shock at some point in your life. And then we also have electrical burns. And electrical burns are we'll talk about those in a few minutes, but electrical burns are very, very serious injuries. Now, we also have these indirect causes, and mainly what we see is those result in falls. So those are the four main areas we're looking at today: of preventing of electrocution, shocks, burns, and then indirectly falls. So how do we get a shock? Well, for those who've experienced a shock, and usually if I had cameras on and we could see, if I asked how many received a shock, well over half of you would raise your hand. Every once in a while, I get the entire room to raise their hand that they've received a shock, but most of us have received a shock at some point in our life. And we get that whenever we have a voltage, we come in contact with electrical current, either by touching a wire or some other conductor in the system that's exposed. And we have a voltage potential difference. So if the wire is at 120 volts and I'm not, and I touch it, now I'm going to be at 120 volts, and the current's going to flow through me back to the ground, trying to get back to the source. So that's how we get a shock. We can also get a shock by touching two different wires that are at different voltages. You know, in a single phase system, you have 120 volts on both sides. They're off by a 180-degree sine wave. But if we touch either of those wires, then we're going to get a shock. If we have a three-phase system, obviously any of those phases are at a different cycle. So if we touch any of these wires, we receive that shock. So as I said, most of us have probably received a shock at some point in our lives. And so if that's the case, why are we all still here, right? Well, the severity of the shock depends on the path. So where did the current flow through your body? How much current went through your body? And then how long was the current flowing through your body? So those are the three main elements. Now, I contend that most of us have received shocks that in the 120 volt range. You don't think much of it because you got a little zap and you went on. Well, what I contend is that pathway to the ground isn't a very solid pathway. So, if you received a shock and you're on maybe a carpeted floor or a wooden floor, you don't have a real good, strong connection to the earth. Therefore, that pathway to ground isn't very strong. So you're going to get some current flowing through you, but not a tremendous amount. Now, if you do that same activity, say on a wet basement floor, you're going to have a very different outcome. So that pathway to ground makes a big difference on the severity of the shock. Now up here we have low voltage does not mean a low hazard. Many of you probably know that the OSHA standard or the National Electrical Code, they come into play at 50 volts or more. So at 50 volts, then I have to follow all of the regulations. When I drop below 50 volts, I'm outside of the OSHA regulations. They don't cover that. But does low voltage mean I don't have a hazard? Absolutely not, especially in today's world where we have these large battery banks that run at tremendous number of volts. Yeah, I mean, well, not really high voltage, high current, high amperage. So, I worked with a guy one time a few years, just probably 20 years ago. He welded his wedding ring to his engine block by the car battery. He was working on the car with the car battery. You got the 650 cold cranking amps went through his wedding ring, welded it straight to the engine body or engine block. So that these things can happen. So that's a 12-volt system, but it can do tremendous amounts of work or hazards. So be aware of that. The low voltage does not mean low hazard. There's still tremendous current flows in some of these, especially now we have these large battery banks that have tremendous potential current flows. All right, so what are the effects of electric current? So here I've got a chart just showing what happens to the body at different levels of current flow. And those first four are all talking milliamps. So a milliamp is a 1,000th of an amp. So very, very small amounts of current. And at 3 milliamps is when you start to feel like you're going to get shocked. I mean, that's when you have more than just a tingling. It's a painful shock. Now that 10 milliamps is what we call the no let go threshold. So if you were holding a current or some sort of conductor and you had a hold on it, and at 10 milliamps, you may not be able to let go. Your muscles are going to be contracting and you're not going to be able to let go of that line. Now that's a very bad situation, right? If I had a metal tool, for example, and I'm holding it and I've got 10 milliamps, I just keep squeezing it harder. That's a problem, right? Because if we look at what's the severity of the shock related to, the amount of current, how long I'm in contact with it in the past. So if I hold it, my duration keeps going up and up and up, right? So I get more and more current flow through my body. At 30 milliamps, we can stop breathing. 75 milliamps is when we start to have really serious complications here, heart fibrillation. Really, we start looking at those, even at 4 milliamps, 4 amps, 5 amps, all of those sound really bad. Tissue burns, heart stop, heart fibrillation, breathing stops. Any one of those situations does not sound good. And the reason I look at those from 5 amps and below is our circuit breakers, these things that protect our systems from overcurrent. The smallest that we're going to typically see in a residence is 15 amps. In a commercial building, an industrial building, it's going to be 20 amps. Wow. All of these things happen at 20 amps or below, right? Even tissue organ damage. So those overprotection devices on your system are there to protect the equipment. They're there to protect the building structure, the electrical equipment. They're not there to protect you. So we have to then talk about what's in this electrical system that protects us from injuries. So electrical shocks, as we just saw, 75 milliamps is enough to cause that ineffective heartbeat. You're just fluttering of your heart. Your heart isn't pumping in the right rhythm. If you don't get shocked into the right rhythm quickly, you could die from this. So it's 75 milliamps. It's not a lot of energy. And this is just a 100-watt incandescent light bulb. Yeah, this is what they look like. This uses 830 milliamps of power. That's 11 times more than it takes to send your heart into fibrillation. We think 100-watt light bulb, that's not much, right? But that's enough to 11 times more than you need to send your heart into fibrillation. So that's a phenomenal amount of current flowing through a light bulb when you look at how little damage it takes to do damage to our body, how much current it takes. It's not much. Electrical burns, one of those common direct contact injuries, very common in the hand. It's the most common non-fatal injury. And it happens in our hands, obviously. That's where we're doing the work, right? That's what ends up touching the conductors. They're very, very serious injuries. You need immediate medical attention. If you get shocked and severely shocked, you want to have this looked at by medical professionals, because there can be internal tissue damage that went through your body, and it may not be apparent initially, but it will become apparent as you've effectively cooked the inside of your body. So you want to seek medical treatment so that those issues can be addressed readily and quickly to have a better outcome. So electrical burns, they can be incredibly serious, and they need very quick medical attention. Indirectly, we talked about indirect exposures, and these are falls is mainly what we look at from a high number of injuries. So electric shock, what happens if you get shocked? If you're this guy on this ladder, right, you're up here working on a circuit and you didn't follow your right protocols, you didn't use lockout, tag out. So you're up here working on this and you get shocked. What's your reaction going to be, right? You're going to pull back. And when you pull back, you're probably going to lose your balance. So you've gotten shocked, you pull back, you lose your balance, you fall. Now, sometimes you fall a foot, sometimes you fall 6 feet. Well, whenever you fall, you never know what the outcome's going to be, right? Because you don't know how you're going to land. And that's, even falls from 5 feet or less can result in death if you hit your head the wrong way. So these falls are a big risk of injuries. And this is where lockout, tag out comes into play. If I'm going to be working up on any electric system, I need to lock it out. Now, as a safety professional, Brad and Jim and I, we're required to use certain slides in our presentations. And typically there's one of two slides we have to use. Now, one that you'll see often, and I want you to think back to some of the safety presentations you've seen. One you see often is a triangle. And sometimes it's a triangle and it may be on point. You know, sometimes it's the pyramid, you know, whether it's Heinrich's pyramid or the fire triangle or the ergonomic risk factor triangle. You know, that's one of the things we have to use in a presentation. Well, in today's presentation, I don't have any triangles. Therefore, by default, I have to use this slide. And this slide is the OSHA typical or most cited citations for the electrical hazard. So, you know, there's our 1910 300 series, which is the electrical section of the OSHA regs. And here's what OSHA cites most frequently. You know, proper installation, using extension cords wrong, grounding permanent effective. We're going to talk about that. We're going to talk about extension cords. We're going to talk about strain relief. We're going to talk about pull junction boxes and covers. So, I mean, all the stuff we're going to talk about here, these are all the things that OSHA cites most frequently. So there's my slide. I have fulfilled that obligation. All right, let's move on to these hazards here that we have. So inadequate wiring size is a hazard. So remember those fun equations? So if current flowing through a wire creates heat, it creates heat at the square of the current. So the more current you have flowing, the more heat you're going to generate. So and then plus there's the resistance of the wire. So if I have a bigger wire, I can put more current through it and generate less heat or not generate too much heat. So that's why you see, if I have a lot of current flow, I need a big wire. If I have a small current flow, I can use a small wire. If I put a lot of current through a small wire, it's going to generate a lot of heat. Oh, I'm going to mention the fire triangle, right? What's one of the sides of the legs of the fire triangle? Heat, right? So heat is the source that we need to start a fire. Yeah, sometimes you say it's ignition, but heat is sufficient as well. So in this case, heat is a bad thing, right? We generate too much heat, we can catch things on fire. We can start burning the insulation off the wire. We can catch surrounding materials on fire. So it's a very, very common outcome is faulty wiring leading to a fire. So inadequate wiring is a hazard, and we'll talk about that a little bit as well. Here we just see an example of different wiring sizes. So we go from there on the left-hand side, very small wiring, handle up to 20 amps, typically 20 or 15 amps. As you get, and then you go across, you see larger and larger wire sizes can handle more current safely. Overloaded circuits. Oh, I'm not going to ask anyone to look behind their desk, but does it look anything like this? Well, so we start plugging in too many devices. We start drawing too much current for that device, back to that Watts equation. So we use too much current, we generate too much heat, we lead to fires. This is our concern with overloaded circuits, is causing a fire. And in here, some of you are looking at this and you obviously see a couple of the relocatable power taps, or we call it surge protectors, or whatever we want to call them. Here we got a daisy chain. We got one plugged into another. We all know that that's incorrect. But for those who think that that's an acceptable option, it's not, right? A power tap is to be used in accordance with this label and listing. And that says, hey, I got to plug this directly into a outlet receptacle. I can't daisy chain it into an extension cord or into another power strip. It's got to be plugged into the wall. So that's how they've been approved to be used. That's how we have to use it. And label and listing is a critical aspect, and everything has to be used in accordance with this label and listing. So electrical safety devices that protect us from overloads, we have fuses, circuit breakers, and GFCIs, what we're going to put in this category as well. But fuses and circuit breakers, they protect on overcurrent, so they melt. Fuses melt, current circuit breakers trip open when there's an overload. So that's how those work. Now, GFCIs work a little bit differently. GFCIs are going to monitor the flow of current out on the hot wire and back on the white wire, the neutral wire. And so it's looking for, remember, if current flows in that path or in that circuit, right, always back to its source. So what goes out of this outlet needs to be coming back. And that's what these devices do, is they monitor what goes out and what comes back. And if it sees a difference of 5 milliamps or less, it says, hey, 5 milliamps or more, excuse me. What it says there is, we've got a problem, right? There's some current that went out that didn't come back. I'm going to shut off the circuit in case somebody is in contact with this circuit and is getting shocked right now. And it does that in a 40th of a second. So very, very quickly. So you get a little jolt, power shuts off, and your life is saved. That's how these things work. GFCIs are amazing, amazing devices. They save lives. And we see these in anywhere we have the potential for a fault to ground. Obviously, you see them typically around water applications, so near sinks, bathrooms, those sort of things. But we also see them outdoors where we have good connection to the ground, unfinished basements, garages, anywhere where we have a good potential for that current to flow through our body into the ground. We're going to see a GFCI required by the National Electrical Code. Now, grounding is a second method that's used, and this is an older method than the GFCI, but it creates that low pathway of resistance to the earth to disperse that unwanted current. Here I have this old metal drill. This is my father's drill. It's a beautiful piece of equipment here, but it's got a metal casing, right? And what do we know about metal? It's conductive, right? I'm squeezing this. Now, if a wire inside of this drill were to come frayed and get in contact with the outside casing, it would be sitting there charged and energized until I grabbed it. And then when I grabbed it, I'd be getting shot. And I'd be getting shot probably more than 10 milliamps. I wouldn't be able to let go. I'd be getting shocked maybe to the point of death. So that's why something like this needs to be grounded. And it is. It has a grounding wire on it. So there's a wire that connects to this metal casing. In the event that that wire does become frayed and touches the casing, it creates that pathway to ground, trips the breaker instantly. And so even before you pick it up, the breaker has been tripped as soon as there was that fault detected. So some of you may have experienced this. You plug something in, and as soon as you plug it in, the breaker trips. That means there's something going on in your tool, whatever you're using, that had it short-circuited right away, trip the breaker, protect your life. And here's some examples of things that are improper grounding. Now, OSHA uses this term, and I want you to remember this. The term, the pathway to ground must be permanent and continuous. And that's critical. Permanent and continuous pathway to ground. We always need to have this pathway to ground. And here we have some examples of missing ground pins. I love the one there in the top right. We have an extension cord that allows the ground pin not even to be plugged in. So any of these things, we no longer have a continuous and permanent pathway to ground. And then there in the lower right, we see a broken strain relief. So we have exposed wires there as well. So things, these were all listed in that most frequently cited OSHA slide. Now, you say, Steve, I've got tools that only have 2-prong adapters. I can't plug it in and it doesn't have a third ground pin. Well, OSHA says everything has to be grounded or be double insulated. And when we talk about double insulated, you're going to either see on the tool the words double insulated, or you'll see that symbol, a box within a box or square within a square. And that means it's double insulated. It means that it doesn't have this metal casing on the outside. It's got something that's non-conductive that keeps the electrical side safe from the outside where you're going to be touching it. So it's double insulated. Or we could use a drop below 50 volts, that sort of thing. We could also using tools that get us outside, but most of us use battery operated tools anyway because they're phenomenal now. But yeah, so OSHA says every handheld tool has to be 3-wired. Any tool you plug in your commercial or industry is to be grounded or double insulated. Overhead power lines, they're not insulated. I have the word usually not insulated in the hopes that someday maybe we'll find one, but no, they're not insulated. All these wires are uninsulated wires. They've not been, and you may look up and see, hey, there's a black coating on that wire. That is a weather thing. It just protects it from corrosion. It has not been rated for human touch, so it's not considered insulated. So any of these overhead power lines are uninsulated. You have to approach them as such. So even like in your yard, if you're having somebody come in and do tree work and they're like, oh, I can work around that, I don't need to cut the power. No, that's wrong. That is a live wire. It has to be approached as if it is live, which means I have to stay at least 10 feet away, and anything I put up near it has to be insulated, right? So these are some examples of equipment that gets us too close to these things. And if we operate a crane, we set up a ladder, scaffold, backhoe, scissors lifts, anything that brings us up closer to the wires, we end up with these risk of hazards. Raised truck bed of a dump truck. That one's pretty common. You'll see a raised bed of a dump truck drives into an overhead wire, and usually the outcome's horrible on that. I had a cousin actually, that was how he died. Raised bed of a dump truck into an electrical line. So overhead power lines, again, OSHA says I got to stay at least 10 feet away. Post warning signs, if I have overhead hazards, always assume that everything's energized. That's your safe assumption. So it's energized, stay away. OSHA says I need to use fiberglass ladders. So non-conductive side rail ladders. And then if I'm a power worker, I have special training. So those guys are like Superman. Guarding of live parts. This is the next area where I see we fall short often, which is OSHA says I have to protect people from accidental contact with electrical conductors. So anything that's going to be charged or has current on it, I have to keep you from getting in touch, being able to touch it. So that's why we have box covers on your light switches, on your outlet boxes, your panel boxes, your disconnect switches. They're all covered, right? So that you don't come in contact with the energized equipment inside. That's the best way to handle it, is to cover all of this equipment. There's also some other provisions where you can have like a high voltage room or cabinet or enclosure where only qualified persons can enter. But yes, if there's still exposure to shock, then I have to enter it properly, one, properly trained, but two, with the proper PPE on to enter it. Or OSHA has this, and this is one of these bad gray areas where it says, hey, if I have it more than 8 feet off the floor, I don't need to guard it. I don't need to cover it. Well, 8 feet off the floor is great, but I can almost touch 8 feet. If I stand on my tiptoes, definitely can touch 8 feet with my fingertips. So 8 feet's not high enough. And secondly, as soon as I stand on any sort of thing to gain elevation, whether it's a ladder or a step stool or scissors lift, I'm closer to it, right? So no, that 8 feet no longer works. So you want to guard all of this equipment, keep people from accidentally coming in contact with it. These are some examples of some, well, right on the left, you have these open junction box covers. So it's missing a cover plate. It's got openings on the side, those opening knockouts. These are all hazards. These are easily cited and easily enforced things for OSHA, right? It's a presence absence thing. Did you have a cover on it or not, right? In this case, no, it's pretty obvious. You didn't have a cover on it. I can take a picture of it. $2,500 later, you go out and you buy a 38-cent cover or a knockout plug, and you got your violation abated, but it costs you $2,500 to solve that. So go back to your facilities, go back to your homes. Do you have anything that looks like that on the left or even on the right here, right? That's an open panel box. All that needs to be covered. The shiny things inside these boxes are energized, and we need to keep from touching those. The other area we get into trouble with is when we start using extension cords. So extension cords give us power where we don't have it, right? So we tend to use these because we need power somewhere else, right? Whether the place was built one way, we have different means, different needs. So we start running extension cords. Well, when we start using extension cords improperly, we end up with some problems. Well, extension cords, they're subject to more damage than permanent wiring, right? Because they're run on the floor, they run behind pieces of furniture. We don't look at them, we never see them. They're subject to people walking on them, crushing them. So they're subject to more damage, and hence they can lead to more problems. OSHA says I can use flexible cabling or some extension cords, but really just this is flexible cabling, not just extension cords. Extension cords are a subset of flexible cabling. So I can drop like a pendant drop or to a light or a switch. Any portable equipment, we all have those things you plug in, right? That you may move from time to time. And even stationary equipment that you move to time to time. You can use those for flexible cabling. These are the things you can't do, and we see these all the time. We use it as a substitute for fixed wiring. So we start using extension cords. Sometimes we actually use the extension cord as a wiring to a fixed box. Sometimes we'll use an extension cord and we'll staple it. Excuse me, we'll staple it to the building structure or wire tie it to the building structure. This is a substitute for fixed wiring at that point, not permissible. We'll run extension cords through walls, not allowed because I can't see what's happening. We can conceal it in ceiling tiles and those sort of things. Can't see it, can't use it that way, not permissible. All extension cords that we use have to be a 3-wire type. They have to have that grounding conductor. And then they have to be marked for either hard or extra hard usage. And you're never going to see those words on your cord sets. You're going to see either the here you can see the bottom diagram there inside the blue box, SJ, which is for hard. And if it was just an S, it would be extra hard. And the J is junior service. It's weird nomenclature, but those are what you're going to see is SJ or S, and that's what you're looking for on all your cord sets. If you don't have that, you don't want to be using it. And then, hey, you have to remove cords by pulling the plug, not the cords. When I start pulling on the cord to unplug something, 2 things happen. I damage the strain relief, start exposing the conductors or at least the cabling inside the outer sheath. So I can see it now. And a lot of times we also then end up leaving the ground pin in the outlet. So now I've damaged my cord twice. I've got strain relief issue. I've got a missing ground pin. So it's no longer permanent and continuous. So yeah, we need to pull any cords we unplug by pulling the plug at the wall and not on the cord. Here's just an example of somebody running an extension cord through a building wall, going to the exterior. I've never worked for OSHA, but I did work for EPA for years, and I did a lot of inspections. But one of the things I've also learned when doing many walkthroughs from here at Workers' Compensation is if I start seeing orange, I want to see where it goes. And so in this case, it's a very easy thing to look for. Are you running, if you're running an orange wire and it goes to the wall, people are going to look to see where it's going. So here's a case where we needed to have a permanent installation. I mean, they drilled through a wall, they get wire outside, electric outside. They obviously needed electric on the other side. Clues that you got problems, breakers that keep tripping, tools that are warm or cords that are warm, you drew too much current, or a GFCI that keeps tripping. You know, those are things that we've got an electrical problem. This could be the GFCI, but oftentimes it's really the piece of equipment itself. We see this all the time. There's a lot of misuses of equipment. Fabrication of extension cords with Romex cables and making your own extension cord using Romex, which isn't flexible cabling, or vice versa, using a flexible cabling to make a permanent installation. We see both ways. They're both wrong. Using equipment that's labeled for indoors, using outdoors, you know, that's not in accordance with this label and listing. And then attaching these sort of things, these little 2-prong adapter plugs, you know, so this side has the ground, this side does not. So I've just permanent continuous has been removed. So another problem, very common mistake. All right, so got some just pictures here at the end, some things we've seen over the years. Here we've got a power strip. There's a couple things wrong here. We got a power strip with an extension cord plugged into it. Obviously, now we have what's on the other side of the extension cord, right? So we may have drawn too much power. We got daisy chaining of cords. Extension cords don't go into power strips, not in accordance with this label and listing. That bright white cable there, that's a 2-wire cord. I don't know if it's a light bulb on the other end, but you start looking at what's that. Is that an extension cord? Is that a light bulb? If it's an extension cord, we got a real big issue there, right? Because it's not a 3-wire type. So you need to follow these things. So look around your home, look around your workplace. Do we have situations that look like this? Another common thing we see, pieces of equipment that overheat. And so they leave the doors open. Now this is an enclosure that was designed to hold any sort of hazard that may occur inside there. It may be an arc that occurs, and we have a lot of energy dissipated quickly. That door is designed to hold that inside that space. When that door is open, it's coming out. So here, this is a big hazard when you leave these doors open because it's overheating. Overheating is a sign you have a problem. Sometimes we'll see this in very hot factories where it's just hot in the summer, we have to do this. Well, maybe we need to figure out how to increase the ventilation inside the cabinet rather than defeating the entire protection system of this cabinet door. Oh, here's the other end of that extension cord. It is a white extension cord. It's a just a, we call it zip wire. Not appropriate, right? It's not permissible use. It's not a 3-wire type. Oh, here's the other end of that cord that went through the wall. It's a power strip outside. Again, not in accordance with this label and listing. And then these sort of things. There's lots of things you can go out and buy in the world. This takes you 1 outlet, makes it 3. It doesn't mean I have 15 amps on all 3 of those. No, these sort of things are useful at times, but dangerous all the time. Be very careful in using these things in your world, whether it be at home or at work. Not really the greatest thing. You can buy all sorts of things, but you're defeating a lot of the electrical safety systems that are in place to keep your house, to keep your workplaces safe. So exercise a lot of caution when buying those sort of adapter things. Here we also see a strain relief issue. So in summary, always use all your equipment in accordance with its label and listing. Now, how is it designed to be used? Are we using it that way? No exposed electrical components. So we need to keep everything covered, right? We don't want to see any of the shiny parts. And then lastly, don't do anything that's going to impede that connection to ground, that grounding connection. So we need to have that ground permanent and continuous back to the source. That's what I have today. I don't know if there's any questions. And there's my contact information if you want to reach out to me later.
Thanks, Stephen. Fantastic presentation. So fantastic. There are not any questions. So very impressive. I think it was great. Very thorough, very layman's terms. You know, we are end users. Most of us are end users. So those are very common. You know, my experience is the exact same as yours. If I can't find any other machine guarding or any safety related hazards, I can always find an extension cord hazard somewhere, somehow.
Absolutely.
So thank you very much for your time today. We just got a comment, very helpful for your work and home. So some good comments. There was no questions at this point. Jim did mention that the October 6th meeting is a Wednesday. So we were half right, half wrong. We put together, made us all right. So October 6th, Wednesday. So again, Stephen, thank you for your time. Any questions that come up after this meeting, don't hesitate to reach out to any of us, you know, especially Jim and Stephen and Brad are all representatives of the Ohio BWC. So they are here for you. I am here. We are here for you as well. So if there are any questions that you have now or that come up throughout the day or next week or so, please don't hesitate to reach out to us. Just a reminder that there will be a Speedway gift card drawing after the meeting. Be a survey also sent out. So please fill out that survey. Give us any kind of suggestions that we can do better, because you're stuck in this Zoom format for a little while longer. So hopefully sooner rather than later, we'll be able to get back into meeting each other, having breakfast, and enjoying that more than we are here. So with that said, everyone
Hey,
enjoy.
Justin.
Yes,
Hey,
I'm sorry.
Justin.
Yes.
There is one question. I asked Laura Orcott if we can email this presentation.
That'll
Yeah, I'll email it to the Safety Council and they can distribute it. Sure.
Okay. Thanks, Sam. Okay. With all that, have a wonderful day and month, and we'll see everyone back here in August. Thank you, guys. Bye.